Okay, fighting money laundering. One of the big topics today, and the case study or use case today will be with graph technology. And I'm happy to welcome Mario Werner on stage from TigerGraph. Mario, can you hear me?
Yes, I can. Hello. Can you hear me as well?
We can all hear you crisp and clear. Now, are you able to turn your camera on? I see you did before, or I saw you did before. There we are. Okay.
Great. Hello, everybody.
Hello. Okay, I think we are ready and set to go. To the audience, Mario Werner is Regional Sales Manager DACH at TigerGraph, and he will be presenting graph tech use cases specifically in money laundering. And will, I guess, introduce himself in detail. So for me, just to hand over to you.
Just a quick organizational technical question. So, can I go through the slides or?
Oh yes. You can go through the slides. If you hover over the middle part, there should be.
Okay, great. Yeah.
Okay, I'm here to help you out. Won't go away. Just deactivate my camera. All right. Good. Over to you.
Yeah, thank you, Timothy. Yes, hello, everybody. My name is, as Timothy mentioned, Mario Werner. I'm the Regional Sales Manager for TigerGraph for the DACH region. And my topic for today is fighting money laundering with graph analytics and machine learning. Yeah, let's start, as we have only 20 minutes. Before we go into the technology, let's hear what the analysts have to say about graph technologies. Gartner says that in 4 years from now, graph technologies will be used in 80% of data and analytics innovations, and that is up from 10% this year. And thus facilitating the rapid decision-making across the enterprise. So not only we at TigerGraph, but only Gartner thinks it's not a question of when you will start to use graph technologies. The question is not how, if you want to do it, the question is when you will start and the vendor you want to go with. Actually, we at TigerGraph think that graph analytics is an ideal technology to support AML efforts in financial services institutions as it overcomes the challenge of uncovering relationships in massive, complex, and interconnected data sets. This is, since my time here at TigerGraph, I've been talking to a couple of financial services institutions in the DACH region. And having this contextual, it's not about the amount of data, it's about getting context out of that data. That is what many of these financial services institutions are struggling with. And we think, and we do have customers that confirm this, that graph analytics can play a big role in getting this contextual information out of all your data silos that you have already in place in your institution. So let's think a little bit about what AML means. Firstly, it's not small, 1 to 2 trillion of US dollars globally per year. AML, it's not just banks, it's retailers, casinos, real estate agents, gangsters, terrorists, cryptocurrencies, all kind of entities that are involved and need to be involved in these AML activities, not just inside the bank. It's more than just risk scoring, as the threat vectors get more complex. It's not just a simple threshold that you set and then you get a suspicious activity report. It's about getting deeper, wider, and faster investigations and analytics of your data. It's not only about know your customer. It's know your customer's customer. Sometimes it's about knowing your customer's customer's customer. So the traversal of that data is getting more and more complex. And of course, it's not just humans. With graph analytics, we want to support the existing investigation teams, AML investigation teams in financial institutions, together with machine learning, AI, and data science, to be more efficient and to better identify money laundering activities. So I want to give a very short introduction to graph analytics. So actually, graph has been around for decades. I think 4 or 5 decades ago, it was called a network database. But actually, our graph is pretty much reflects the way we think. It's about gathering data and organizing it into types of data and relationships between those type of data. So it's a very natural model for transforming data into knowledge and insight. And this is what we actually, the value that we add when it comes to supporting AML efforts in financial institutions with that technology. To give a very short explanation, a graph is basically a database, but it's not a relational database where you store your data in a table with rows and columns. It's not a key value store where you store keys and respective values that are in most cases, or in many cases, JSON documents. A graph database is a different storage model, and it consists of vertices, also called nodes, and edges. And a vertex is a data entity, and that can be, for example, a person, a human being, an account, or a transaction, real estate, whatever you can imagine. And then you have the edges, and these edges represent the relationships between those entities. And that can be, for example, a person opens an account, that's an edge. Or money that moves from one account to another account, that's an edge. So a graph database stores the relationship between data and entities. And graph analytics goes a step beyond just storing that information. Graph analytics can be used to uncover hidden relationships between those data entities using this data storage model. And this is why we think that graph analytics is a perfect technology to complement your existing AML efforts in your financial institutions. So what is graph analytics about? Firstly, it's about, this database part, it's about connecting data sets and data pipelines. We have customers that connect more than 200 data sets and pipelines, or data sources and pipelines, in there, what they call the brain of the enterprise, which is the distributed graph database. And that is, in that case, a healthcare provider from the United States who is using it for a customer 360 application. And the second step, we analyze that connected data. And as we are talking about relationships between data entities, we can do that magnitudes faster than current solutions that are predominantly residing on a, let's call it a traditional relational data model. I have an example here, Jaguar Land Rover. They have implemented TigerGraph in their supply chain planning application, and they reduced the query time for one single query from 3 weeks running on a relational database down to 45 minutes on TigerGraph. Another example is China Mobile, the world's largest mobile phone provider. They are using graph technology for fraud detection, and they have gone from batch to real-time fraud detection for 300 million calls per day. And the second step, the third step after connecting the data sets and pipelines and analyzing this connected data is improving and amplifying your machine learning algorithms. As we create new metrics and new features based on our graph technology, we can easily feed these new metrics and this new data into your existing machine learning platform, and thus increasing or improving the models that you run on your machine learning platform, and further improving the results. So I mean, it's always about more training data, the better the results. And we not only add more, we also add more sophisticated data into your machine learning platform, and thus improving the results you get out of your ML. So what are the key features of graph analytics? Deeplink, pattern discovery. It's about connecting data entities via their relationships, and with graph technology, you can go from a couple of hops to 10 plus hops. We have customers that are traversing data points over 20 plus layers, and that is especially interesting in a case where you want to, for example, identify money laundering activities, where a source account might put 3, 4, 5 layers of, let's say, mule accounts before he transfers the data to the actual target account. And using traditional technology, you have to do a lot of table joins if you are able to do that at all in a reasonable time, to identify the connection between the source and the target account. And we can do that here easily within in real time, as the data is stored. So the relationship between the data entities is stored within the data itself. We can handle that at massive scale, from gigabytes, hundreds of gigabytes, to terabytes, to petabytes. And we also offer an in-database analytics engine. TigerGraph has an open source, it's available on GitHub, user extensible graph algorithm library that runs inside the database. And thus, you don't have to transfer that data and these enriched features of the data into an additional analytics platform. You can analyze the data where it is stored, which makes it much faster to analyze the data and much easier, less complex to analyze the data. Let's look at a couple of key data science capabilities that are powered by a native parallel graph. First, it's this deep link analysis, which I think personally is one of the foundational features that makes graph-based analytics so important and interesting for AML applications. It's about showing all the links and connections between a given set of entities. Second is pattern matching, identifying similar patterns in a given set of entities, maybe fraud rings that have a certain pattern of activity where you can learn from and identify other fraud rings that have maybe the same pattern that show the same pattern of activity. Maybe we can also look at this fifth and sixth capability that we mention here. That is location data that can be added as a feature to the data, and in combination with the temporal data that we can add to the data entities, we can observe how entities or rings of fraudsters move regionally over time to identify fraud rings and anti-money launderings as they move across the globe, for example. Yeah? These are all key data science capabilities that can easily be delivered with the graph analytics platform. And also very important when it comes to machine learning is that you can extract all these features, all these additional metrics that you can generate based on that platform, and feed them into your machine learning application or into your machine learning algorithms to further improve the results. Better training data obviously leads to better results of your machine learning algorithms. Okay, after that short introduction into graph analytics, let's try to make the case for graph analytics, especially when it comes to anti-money laundering. Just an example, a top US bank, one of the top 5 US banks decided for 2 reasons to use TigerGraph for their advanced analytics AML platform. They wanted to reduce the percentage of false positives in their AML investigations in real time. And they also had a need to uncover these deep link or non-obvious relationships. Results, increasing the accuracy of in reducing false positives by 10%, and that resulted in 20 millions of saving due to more productive and more precise investigations. And it also led to an immediate saving of up to 4 million per year by avoiding fines from regulators. That is obviously a result of uncovering deep link on non-obvious relationships where you can very quickly react to potential money laundering activities. Yeah, let's get an idea how deep link analytics can help to combat money laundering. It's just a few aspects, and that varies obviously by customer and by the actual use case. But to give you some ideas, it's about entity resolution. You need to disambiguate data entities. So to have a clear understanding, what is this data identity representing? A person, a company, real estate, whatever. It's about entity matching. You want to match those data entities maybe to known terrorists, to gangsters, to tax evaders, whatever. The network flow analytics is very important. What we see, it's to map fraud rings to money flows. So from the source accounts to the placement of the actual money, the layering into maybe 4, 5, 6 subsequent layers of accounts where you transfer money to until you finally integrate the whole amount back into the source account. It's about pattern matching, search data to uncover patterns of suspicious financial activity. And it's about traversing the data connections to uncover suspicious behavior. That would be almost impossible trying to get that information with a, let's say, traditional or one of the known AML features. Applications, sorry. This makes this Deeplink analytics case pretty clear. You have two accounts at the top, account 1 and account 2, and they want to send to the two accounts at the bottom, account 21 and 22. They have 3 layers of accounts that are marked in gray. And that results, if you want to traverse only one pass of that data from the source account to the target accounts, that would mean you had 8 data links that you need to analyze to get the shortest path connection from account 1 to account 21. And that is very easy and very quickly in real time achievable using a graph technology where this information is already stored in the data compared to a traditional relational database where you had to create multiples of table joins to get even close to to analyze the data flow as quickly as we can do that in a graph analytics platform. So legacy systems are pretty limited in their functionality. So they're doing their job. We're not about to replace legacy systems. So they are really good for the things that they have been designed for, maybe 10, 20 years ago, but they, in most cases, lacking the depth of contact. Sometimes you can identify mule accounts, but identifying fraud rings or these 5, 6, 7 layer money laundering activities is getting almost impossible. Heavy overhead included, and they definitely lack speed, scale, and insight into connected data. So our customers are using TigerGraph to complement, not to replace their existing, in general, fraud detection environment, or especially their anti-money laundering application. So as we can connect hundreds of data sets and pipelines, we can, of course, also use legacy AML applications as a data source for the advanced analytics that we can offer with TigerGraph. We use all that data to extract these features to give you these new and additional metrics that we can produce with this graph analytics platform, like suspicious activity patterns or neighborhood graphlets, just to name two of them. We can then even enrich every node, every data entity with these features that we have generated using our graph analytics model. We then can feed this data into your machine learning model, either directly inside our graph database, or we can export them into your, let's say, into your Juniper notebooks to run your existing machine learning model in the environment that the data scientists are using. And then we can either use this, use the model to test these incoming transactions. We can directly feed the data into the incoming transactions to issue suspicious activity reports and visualize the data either with our own toolkit or with existing visualization tools, depending on the user of the data. That can be executives, senior executives. That can be money laundering analysts. That can also be people from the IT department, database administrators, operational analysts, whatever. And this is how we can complement your existing fraud detection and AML infrastructure with this advanced analytic feature set. And as I am very close to the finish of my talk, I would just like to point to a customer of ours, Brad Spears, Executive Director from JP Chase, who joined us 2 weeks ago at our Graph and AI Summit. He made a good point by using this picture of this hairball that is used to get more nuanced insights by using the TigerGraph analytics platform. And he said that you can turn this initial hairball of data and connections into nuanced insights, like which portions of my graph, whether it's supply chain or customers, whatever, are low risk or high risk. Then machine learning can leverage those nuanced insights, turn those more nuanced inputs into better models. And this is how he put the benefits of TigerGraph and graph analytics for the fraud detection activities at JP Chase 2 weeks ago. Timothy, is it, do we still have time left? I think I stole you a minute or so.
You did. If you can wrap it up now, then we can stay on time.
Yeah, so that was it from my side. I just wanted to point out that we have some downloads available in the handout session. Just a little information about TigerGraph. I will stay in the chat for a couple of minutes, or depending on how much questions you have, even longer. Yeah, happy to answer any questions or get in contact with you.
Excellent. Thanks very much for the presentation about GraphTech and the intro to these use cases. I will now bring you off stage and make room for the next presentation. Thank you very much, Mario Werner.
Bye-bye.